Alright, so we're going to start doing mechanism design specifically for the shooter subsystem now. And it's going to be an arm shooter. If you remember, we had that circle design for the sprocket. I'm going to create a new document in my folder called 24C arm. B I'm going to reserve for bumper, so I'm going to move up to C for my subsystem. Now once that's loaded, I'm going to start deriving the sketches from both my main sketch and the drive sketch stuff that I need. So first, I'm going to go into my folder for Minibot design, and then the special film one that I created. I'm going to go into the drive. I have to create a new version of it, and so I'm going to look for the sketches for the bumpers and the shooter and the size box, because those will kind of be important to the part that I'm looking at. I'll also derive in the components from the drive file, the 2-bit and gusset drive file, because that's where I had a lot of my sketches for the mounting positions. Bring in the drive and the mounting tube. Alright, so now I have my mounting rail position here. This is the inside of the mounting rail. So I'm going to do a sketch on that plane. I'm going to create a tube that centers on this this pivot point that I have for my shooter. So I'm going to make that equal so that it is also 2 inches. I'm going to look for the center mark of this rectangle, and I'm going to make that incident to the center line that I have for my pivot point. This is my pivot point here. And I want this distance to be about, I want to have like at least an inch away from the pivot point, so I have enough material for the hole that's going to be there for the dead axle. And let's look at this height real quick. It's actually just under 5 inches. So actually what I'm going to do is I am going to just measure the height to be 5 inches. That way this whole pattern offset will be kind of like a normal offset. So I got that, that's 5 inches. And then I'm going to create a hole exactly where this pivot point is going to live. When I machine this, I'm not going to actually care too much how big this hole is. It just needs to be big enough to fit the fastener that's going to hold the shaft. So I'm going to make this something like 0.5 inches. Okay, now I got my sketch. I'm going to go ahead and extrude that. And then I look at it. It's going the wrong way, so I'm going to flip it to go above the tube. All right. And then I'm going to use my tube converter tool to make that into a regular hole patterned tube. So now I have my hole pattern. Next, I'm going to design a gusset that holds this tube to the side rails that are mounted on top of the drivetrain. So I'm going to select this face, and then I'm going to make a sketch on it, and then I'm going to do a couple of different hole patterns. I'm going to do one at the bottom that's going to start at this bottom corner, and I'm going to do another one at the corner of the vertical tube. I'm going to hole pattern this so it goes 2 across and 4 up. Change that to 0.5 so it matches my spacing. And on this one, I'm going to go to the left, and we'll go about, I think it's 7 across. Change this to the spacing to 0.5 as well. Oh, not 35. And then this direction we're going to go 2. Cool. Now I'm going to create the corners of my gusset, so I am going to create circles at each of the corners. Now I want all these to be 0.75 inches, so I'm going to dimension 1 to 0.75. And then what I'm going to do is I'm going to select all of them so they highlight orange, so they're all selected. And then I'm going to press E for equality, and that's going to force them all to be equal to each other. So it's going to apply the equality constraint to all of them. Next, I'm going to create a bunch of lines that touch each of the outer circles here to create my profile of my gusset. And I'm going to use the tangent constraints to lock in all of the lines so that they are just touching those circles at one point. Let's try that again. And sometimes when you're going fast, it locks in additional constraints that you don't mean to, so you just Control Z a couple times, back up, and then try again. Now I'm going to create a gusset that, or a plate, I guess, that centers the hole here. And because we get the tubes, two pattern holes done by the mechanical engineering shops, I don't typically like to ask them to do custom holes in like random spots. So what I'll do is I'll design a plate that will mount to the side of the tube to get my precise hole position. So we can do that in-house on the OMEO. And so what I'll do is I'll just drill a hole like that one, the large one in the center, by hand on the drill press, just to allow enough room for a pass-through so that I can use the plate as my actual centering hole. Same gusset design philosophy here, do all of my hole pattern, my corner holes for the exterior of the gusset, and then lines and tangent constraints to make all of that hit at one place at each of the circles. Both of these are going to be 1/4 inch gusset plates. So I extrude them to a 1/4 inch, and now I have my gussets. Now this is actually for the arm pivoting position. This is kind of all I need. I'm going to go ahead and rename my part studio and my assembly to my naming convention 24C arm and then arm assemb for assembly. Now I'm going to go to the assembly and I'm going to drop in the parts that I currently have to start creating my arm assembly. So I'm going to drop in all the parts, and then if I press the green check mark and not drag around the screen, it'll drop it in exactly where it is in the part studio. So what I'm going to do then is I'm going to lock these two together by grouping them. This blue plate I actually want to be on the inside of my assembly, so I'm going to move that to the other side. Next, I know that from interior to interior of the mounting rails on the side of the drivetrain is 22.5 inches. So I'm going to use a linear pattern here to move these to about 22.5 so that they match that dimension. So I'm going to put 22.5 here to see where it's at. This is not exactly, it's going to be something a little bit more than that based on the tube width, but instead of doing the math, I'm just going to drop it in first, and then I'm going to look how far apart, and then I'm going to adjust. So these are 21.5, so I'm going to add an inch to this, so it's 23.5. And now it should be 22.5 on the interior face, which matches the drivetrain. And then I'm going to copy this over so that I can mount it on the other side as well. And then I'm going to do a linear pattern with these gussets so that I don't have to mate them over again. I'm going to go in the direction of that edge, and then I'm going to go to the other side. Oh, actually, I'm just going to go to the other side of this one tube. So 21.25 gets me on the other side of the tube because the plate is a 1/4 inch and it needs to travel an inch plus that 1/4 inch to account for the thickness of the plate. Then I'm going to select both of these, same thing, go in that horizontal direction, and now I'm going to go about 22 inches about. So I need a little bit, 22.5, I need a little more, 23.5. Cool, so that looks like it's just about right, good. So now I have the plates that are holding it to the drivetrain. This is 22 inches in between these plates. So now I'm going to create a hex shaft using MKCAD to 22 inches. So I'm going to search up hex shaft, 1/2 inch hex shaft is what we use. We're going to do, it's going to be a bolt and washer situation, but we're not going to include that in the hardware here. Gonna make the shaft 22 inches and made it to the inner circle. Boom, boom. Cool, and now I have my shaft that goes across the arm for my dead axle. Cool, so we just have 3 parts here. We're gonna rename them just to make sure we have a name for them for when we do it in the part management system. This is gonna be the arm tube. This is going to be the arm gusset. And then this is going to be, let's call it the arm shaft centering plate. Cool. All right. Now that we have this much of the assembly, I think I want to see what it looks like in the top level assembly. So I'm going to create a version of it and then go to my top level assembly. Oh, I haven't dropped in my drivetrain yet, so I'm going to start with that. I'm going to go to other documents. I'm going to look for in my folder, I'm going to look for the drive. So 248 drive. I'm going to go to assemblies and then select my drive assembly. And that's going to import in. Cool, and now I'm gonna fix it. I'm gonna select the part and I'm gonna create fix. And that's gonna make it so it doesn't move my assembly when I drag things around. Now I'm going to go to my arm, go to assemblies and drop the arm assembly in. And again, I'm not gonna drag it around the screen. I'm gonna drop it in because it's gonna put it right where it's designed. And since we did all of our reference drawings, it'll be right where it needs to be when I drop it in. Okay, so now, okay, I remember there's this intake gusset here, and I'm looking at this interface. The outer plate is fine, but this inner plate is actually not working right with my intake gusset. So I'm going to change that by going back into my arm. I'm going to create another sketch on the inside of this tube, and I'm going to create a new gusset specifically for this purpose here. So I'm going to use the same kind of gusset technique. I'm going to use 1 hole here, and I know that the intake gusset's about 3 holes in, so I'm going to go 5 holes out to make sure that I have clearance from that. I'm going to do a linear pattern here. I'm going to only go 3 up on this one, and then 3 across on this one, and that should give me plenty of stiffness for that tube. I'm going to do my corner circles. And then I'm going to make all of these equal to each other. E. And then I'm going to make it equal to the outer circle of the gusset, which is already the 0.75, so I didn't have to dimension anything here. And now I'm going to go and create all of my lines to create the gusset contour, making sure they're all touching the circles that I've created. I'm going to do the tangent constraint on all of these lines. Oh, got an extra one in there. Okay, and then for this corner, I'm actually just going to use an arc. So I'm going to make an arc touch both of these inner circles, and then I'm going to make them tangent to each of the circles, and that's going to create this curve for me here. And that is cool. So I did the whole thing without any dimensions. It's going to be another 1/4 inch plate. They're all constraints. And this is going to be the inner arm gusset. And so now I have to modify my assembly. So I have to take these out of these linear patterns. So let's go ahead and remove this guy. I'm gonna change, let's see, let's go into my current part studio, get my inner arm gusset. Let's mount this. This 3rd hole is at the top of that guy. Oh, everything moved. That means that it's not fixed. Let's go back real quick. Let's go ahead and click the first part that we dropped in and fix it so this whole thing doesn't move. All right, and now I'm going to do the mate from this hole, 3rd hole up to the 3rd hole up here. And that's all lined up now. Now I need to change my linear pattern offsets so that the first plate that we designed is on the outside. So I'm going to delete this missing one, and then I'm going to change this, add an inch to it to bring it to the outside. Oh, an inch and a quarter. There we go. Now I'm going to do another linear pattern of this interior guy here, going in the direction of that edge. And then this should be something like 21 and a half or 21 and a quarter, 22 and a quarter. There we go. Cool. So now that looks good. Create a new version of that, and let's confirm in the top level assembly that it actually doesn't interfere with the intake gusset. So once I get that blue circle, I can update that arm. So now we see that it doesn't interfere anymore. So we're good there. All right. Since the arm is not a super complex assembly, I'm actually going to include the shooter in this. So I'm going to rename this arm shooter, just because the part studio is going to be relatively small. So we don't necessarily have to worry about crazy load times here because there are not going to be so many parts. So what I'm going to do is I'm going to create a plane off the sketch. I know the node is about 14 inches long, so I'm going to create a plane that's 14 divided by 2, so 7 inches out from the center, and this is going to be where the rail that holds the shooter together is going to live. Now I could do that at 14 and a half if I want to give it a little bit more room, but I'm just going to do 14 as a round number. Again, this is just primarily for showing how to do this. Then I'm going to create a box around this kind of center line of my shooter here. So then I'm going to create a center line that goes from the center of that top line segment to the center of the bottom line segment. I'm going to make this whole line incident to that center line, and then I'm going to do a couple of equality constraints here to make those 2 inches. I'm going to make this perpendicular and this perpendicular. Cool. So now this tube is a 2-inch rectangle centered on that line here. I do want about an inch away from this to make sure that I have enough room for my hole for the pivoting, and then I'm going to make this a round number at 9. So I'm going to go ahead and extrude that, and it's going the wrong way, so I'm going to flip it the other way so that I have the full 14 inches between each of the tubes. And then I'm going to add on the sketch that I just created, I'm going to add another circle centered at my centering plate circle, and I'm going to make that 1 1/8 because that's going to be the size to allow for a bearing to get fit in there. So there we go, and then tube converter. Cool. And then I'm going to make this a 16th inch tube because since it's rotating and we're going to use a motor to rotate that, we want it to be as light as possible. So I'm just going to use a thinner tube here. And actually I wanted to design a plate here because I know that for our sprockets, we'll have holes above and below the main bearing hole. And so what I'm actually going to do is I'm going to extend this tube so that I can have holes on the other side. There's an automatic clearance feature in tube converter that makes it so that they don't create holes near any other features. So that's what's being activated now. And so I'm just going to show here, I'm going to go to West Coast Products. I'm going to look for a 35 chain sprocket, and then show you the hole pattern that I'm talking about. So I'm going to use remember I sized this for a 60 tooth sprocket, so I'm going to look for the 60 tooth sprocket here. And this hole pattern matches with the regular hole pattern that we're working with. These kind of long-ish holes will match the holes that come out when you do the hole pattern, as long as you center the bearing hole on a set of holes. And that's what we're doing by using round numbers when we do our dimensions, is to make sure that all those things fall in the center of a hole. So I'm going to just bump this out by 1/2 inch. I'm going to keep that at 9. And now I should have holes on either side of that bearing hole. There we go. Cool. So I have my holes ready for my sprocket mounting bearing block. So I am going to create another plate that's going to live here. It's going to have the same 1 1/8 interior hole. These are going to be all equal to the holes on the tube. And then I'm going to create another set of circles on the corners. And those are going to be 0.75. I'm going to mention this guy 0.75. Select all of them. And then press E for equal. And oh, missed one. Try that again. I'm going to do my equality straight there. And then I'm going to add my lines to each of the circles. And then tangent constraint. Touch all of the lines. And it looks like that one actually isn't touching the top left circle, so I'm going to use the incident constraint, coincident constraint, and then touch the very tip of the line and then the circle, and it's going to connect them. And then I'm going to continue on with my tangents. This is going to be another 1/4 inch gusset. Boom, boom. All right, so now I have a mounting plate for my bearings and for my sprocket. Cool, and it matches the angle for my shooter. All right, so next we are going to design, let's go with the shooter plate next. And so I'm going to start on the outer face of my tube, create a new sketch, and then I'm going to get the center of each of these larger circles that are supposed to be my shooter wheels. And then this line, if I track this line, it goes to this lower section here. So that is where I want to make my concentric mate. Let's check that's the right one. And then these are going to be, let's see, if I was going to do a dead axle, I'd do a 1/4 inch, but actually I'm going to make this a live axle just to kind of show you how that works. It'll be a little bit easier of a design, and then it'll allow me to tuck my motors in. But we have to just make sure that it's well supported then. So that's going to be 1 1/8 because that's a bearing hole. And then I'm going to make another hole out here that's going to be for the motor mounting. And I'm going to start by making a center hole that's 0.65. So a shaft is 0.5. 0.65 should get us enough clearance around the shaft so that it can spin freely through the hole without touching anything on the plate. Then I'm going to draw a random rectangle around it. And then these are all construction lines. I'm going to cross them over because you'll see I'm going to create like a perfect square around this circle here. So I'm going to make those lines that are crossing over centered on that hole. And then I'm going to make these equal. And then I'm going to make the corner perpendicular. Cool. And from here, so this is the gearbox that I'm going to use for this. It has one side's 2 inches, the other side's 2.44. So I'm going to use those numbers. The side that's going to be, I'm going to make this parallel to the tube. And then the side that's facing the tube, I want that to be the 2.44 side, and the other side I'm going to make that 2. Cool. And then I'm going to do a center line here, and this is where I'm going to use my design calc, that line from the center of that hole to the center of the gearbox, because it's going to be center shaft to center shaft. The plate's going to have about 2 inch material or 2 inches circle around the center shaft. For the design calcs, this is going to be for my shooter. It's going to be a pitch of 5 millimeters, and then 18 tooth pulley is kind of like the smallest we typically work with. So I'm going to use that as a starting point, and then we have some 48 tooth belts. So that's going to get me a center of 2.95. Let's see if that works here. I just want to make sure it doesn't make the gearbox hit the roller. So we're about at 2.9 now. So 2.95, and that gets us so that gearbox does not touch the wheel. I should be okay there. And then I'm going to space this off by about 1/4 inch. There we go. And then so that's going to now lock in. It's going to keep the gearbox close to the tube, so it's not a big weight far away from the tube, but make sure that there's space between the tube and the gearbox. I also know that the gearboxes have a mounting hole that's aligned center to the 2 inch face. So, and it's a 2 inch diameter mounting hole circle. So it's going to be 1 inch away from the center. And then the hole size is the same as the hole size that we've been using for a number 10. It's the 0.201. And then I'm going to do a circle pattern here, but instead of doing 3, I'm actually going to do 2, and it's just going to bring that circle to the other side. So it's kind of like doing a mirror, but when you don't have a mirror line, that's another way you can mirror something. Okay, now I'm going to finish off this plate by capturing the other bearing hole. I'm going to do a line across, and then I'm going to do the mounting holes. I'm going to go about 3 in, so 1, 2, and 3. Centering all of those, equality constraint. Select all of these and make them equal to the first one. And then I'm going to get the back corner ones because those are the ones I'm going to use. Make these 0.75. These two are equal, and then I'm going to do, this one's also going to be that 0.75 as well. Make that equal. Cool. And now I'm going to create some lines. That's going to be tangent to that. That's going to connect. And that's going to connect. And then one more. And then it's going to turn gray because that means it's closed shape. There you go. And then tangents all around. And once all the lines turn black, I know that it's fully constrained with very few dimensions. Gonna extrude it to a 1/4 inch. Boom. So now I have a plate with some mounting holes for a motor. This is gonna be the shooter plate, or sorry, this is the sprocket bearing block, and then this other part 7, that's gonna change to the shooter plate. Cool. All right. So next, before we drop this to assembly, I want to create a plate that goes across the entire shooter. So I'm going to do a sketch on the short side of the tube. And I'm going to make some circles for the mounting. I'm not going to do the whole linear pattern because I don't want to fasten all of those holes. Like, ideally you would do the entire side of this, but I'm just going to select some holes so that when I put it on the CNC router, it doesn't take forever by drilling a bunch of holes. We're only going to space them out so that we'll only use these 5 on each side. And then I'm going to get the outside holes. Those are going to be 0.75. There you go. And then I'm going to do some lines that go from large hole to create the outer edge of my plate. And then from here, I'm going to go from the top edge to the actually just this, like the center of the part studio. So I'll make these all tangent. Boom, 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 boom. Tangent, 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 tangent. Now I'm going to use I coincident constraint, and I'm going to touch the center line of the part studio and click the end of the line segment, and that's going to bring them all the way back to each other so that it goes all the way to the center line. Now I'm going to use the mirror tool, click the center line, and then click all of the parts in this left side of the sketch, and that's going to mirror all of these parts to the other side. I gotta get the actual outer contour, not just the center hole. So boom, boom. Now I should have them on the other side. Good. Let's go ahead and extrude that 0.25. There we go. And now I think with all these parts we could start putting together the assembly. But actually what I'm going to do is I don't like the fact that I accidentally designed this on the top. I want this actually on the bottom. On the top I'm going to have wheels. So I'm going to go back into my part studio, and I'm going to go to that sketch I just did, and I'm going to actually change the sketch plane. I'm going to cross that out, and I'm going to select the bottom sketch plane. And you see it drops the sketch features down, but it messed up some of the lines as it did the conversion from top side to bottom side, which is okay. I'm just going to delete those and redo them. So here, tangent, tangent, mirror, center line, mirror, tangent. Look at the tangent again. All right, cool. So now I have my plate. I'm going to drop in the new parts that I just made. Get the tube, I still need the sprocket. block. There you go. Cool. So now it's going to start forming my shooter. I'm going to do a planar mate that mates the center of this plate, the vertical plane that goes up through the center, to the vertical plane that goes through the center of that shaft. And that's going to make this entire thing centered in the assembly. Next, I'm going to I'm going to mate these two circles together. Okay, and then the mounting hole for the bearing block gets mated together. And then I'm going to do the shooter mounting to the front of the shooter. Okay, that's all mounted together now. Next, I'm going to do a cylindrical mate to the circle of my bearing block to the end of the shaft, which is going to center the bearing block there. And so now it is all spinning around the same axis and centered on that shaft. So now I'm just going to create copies of all these parts because I need them on the other side too. I'm going to mate the bottom of this tube to the corner of, I'm missing the hole there, but I'll fix that later. I can use the circle as my mounting reference, the circular edge that we did, because it still has the same center. To the center of that tube circle. Good. And then I can mount the bearing block circles together. And then so this plate's actually going to flip because I need a motor for the top side and a motor for the bottom side. So I'm going to mate it so that I can have the motor mounting hole flip to the other side. And as you see, as it flipped, it wasn't perfectly aligned, so I can't use a fastener. I'm going to use a revolute, and that'll allow me to pivot this plate a little bit while it's still centered on the one hole that we mated. Now I'm going to get a couple of the holes kind of lined up, and then I'm going to use a cylindrical mate to mount to match the centers of the second holes. So it's hole, hole. Now those are lined up. So yeah, there you go. A revolute and a cylindrical mate can get you the lineup you need when you have something that mounts to holes that isn't quite lining up when you put in the assembly. Next, I'm going to use my Calcs part. So now I have my 1/2-inch bearings that I'm going to mount to the shooter plate. So fasten mate to the circles. All right. Cool. So working on this side, I'm going to actually go to MKCAD. I'm going to look for the sprocket that's going to go on this side. So sprocket, I'm using a 62-35 chain. So I'm scroll down, numbers increasing, 62-35 chain. I'm going to use the West Coast Products one, the WCP X-spline bore. So it's going to drop that in for me. Now I'm going to mate this center circle here to the center circle here. It looks like it's intersecting, so I'm going to flip it. Oh. Yeah, so flip it to the outside. And then check mark. Okay. So now my circles aren't lined up here for the mounting position, so I don't love that. I'm actually going to change this to a revolute mate so I could spin it around. And then I'm going to grab a cylindrical mate, and I'm going to go, remember we're going to go up, everything's rotating with me. So these long holes are what's going to mount to the holes that I currently have on my tube. So I'm going to go to the outer side of the long hole, and then I'm going to pick the circle that I have, and that's going to rotate it. Oh, and it's actually offset 45 on. I need to go to the other side hole. So I'm going to take that. I'm going to remove the mate to the sprocket plate, and I'm going to remate it. Oh, that's actually still a sprocket. I need to do the other hole of this orange plate here, and I can't really see the hole, so I'm going to look from the back side because I can see it from the pass through there. So like that hole. Okay, and now it should be lined up. There you go. So now we have our mounting pattern. All 4 holes have access to the sprocket, so we can mount it pretty rigidly. This whole thing's flipped over. I need to flip back around, and that's the position it would be for kind of its shooting position. Cool. So now this bearing is going to go into this bearing block here. There we go. So now that shooter assembly can pivot around that sprocket as a chain that will be mounted down by the drivetrain. Can spin it. So this thing can move up and down to get my shooter angle. All right. Next, let's go ahead and bring in our motor. So I'm going to search for max planetary. That's the gearbox we're going to be using, and I actually just want a 1-to-1 ratio. We're going to be using a Neo, and then let's do a 2-inch shaft. Go ahead and insert that. And once that drops in, we can do a revolute mate. So change that to revolute. And then we're going to click the center circle of this gearbox assembly. And then we're going to use the circle of my mounting plate. Flip that around. And then I'm going to do a parallel mate from the long edge. Remember, we wanted the 2.44 edge. I'm going to do parallel this face and the face of the tube, and that will make them so that they're parallel to each other, so that they're not touching. See there? All right, and then I'm going to grab that same part from my feature tree on the left, and I'm going to Control C, Control V. It's going to drop in another one. I'm going to do revolute mate again. Change this to rev. There we go. Circle of the gearbox, circle of the mounting hole. Boom. Cool. Flip that over. All right, and then I'm going to do the same parallel mate. I see a problem here already. The plate that's underneath the shooter, the long flat one, is going to get in the way of this gearbox. It's actually going to interfere because remember, it's a 1/4-inch gap between the gearbox and the tube, and this is a 1/4-inch plate, so they're going to like land right on top of each other. I'm still going to mate them to be parallel, but if I look at it, you could see that they're intersecting. Even the actual motor body touches that plate. So this is where our constraint design style is going to help out. We're just going to go back into this. I care about this gap over here. Oh, I missed a tangent there. I'm going to redo that. Care about this 0.25 gap. I'm going to change that to 0.5 and nothing else. Everything's going to re-render. And when I go back to my assembly, I should see now that in here I have a gap between my motor and that plate. So I'm good now. Next, I'm going to drop in a pulley to drive the shaft here. So I'm going to search for pulley. I'm going to use the configurable one. So I'm going to look for configurable only. It's going to be HTD configurable pulley. There we go. I'm going to make this 18. We're going to use 11 millimeter because we're doing a 9 millimeter belt. So I do the 9 millimeters plus 2. The flange height I'm going to do, or flange width I'm going to do 0.1, and the flange height 0.2 inches. Misspelled inches there. Good. Insert. All right. So now the pulley just dropped in. I'm going to take that. I'm going to mate it to the shafts of the motor. So fastened. I'm going to do the bearing first. And I'm going to offset this by a -16th, and that's going to bring the pulley out because you want a little bit of space from your pulleys to your bearing. You'll put a spacer in between there. Then I'm going to copy this pulley, do the same thing on the other side to the bearing hole. Good. Offset that by a -0.0625, not 125, 0.625. Good. Now let's do 0.65. We're going to copy this pulley again, and we're going to put it now on the shaft side. So boom. Cylindrical mate to the shaft. And I'm doing a cylindrical mate here too, so that I could perfectly line it up with the outer pulley. So I'm going to do you see it slides on the shaft there. I'm going to do a planar mate from the outside of the pulley to the outside of the pulley here, and that's going to make sure that they're perfectly lined up with each other. Because the bearing's there, and the bearing's there for the shooter side, but not for the motor side, doing the 16th offset isn't going to actually be equal because they're slightly different due to the bearing being there. So same thing, gonna do cylindrical mate there, planar mate to the faces. Boom, boom. Oop, something messed up there. Let's try that again. I'm gonna delete this planar mate. That looks fine. Okay, let's try that again. Planar mate, outer face, green check, and then we're good. All right. Okay, so next I'm gonna make a shaft that goes from that end of the pulley to the end of the bearing there. That's going to be the effective shaft length that I need. So I'm gonna do hex. That's 17.32. I just copied that from the measurement at the bottom and pasted it in here. You could either do, let's do shaft collar right now. Include everything and then insert. So the shaft then drops in for you. I'm gonna mate this to the outside of that bearing here. Cool, and it goes from the end of the pulley to the end, but it actually didn't put in my shaft collars, which I don't quite know why. So what I'm gonna do is, let me change the configuration. Let's actually do, it's actually nicer if you could do bolt and washer is a cleaner assembly. So let's go ahead and do bolt and washer. Let's regenerate that. And when I zoom in here, you see that it regenerates with the bolt and washer. I'm not quite sure why the bolt and washer worked, but the shaft collar didn't. The tool just might be a little bit buggy. So I'm going to create another shaft here. Do the same thing. I'm going to mate the end of the shaft with the outer side of the bearing. And then, there we go. Now I have the shaft that goes across. Next, I'm going to include my wheel. So I'm just verifying the diameter is a 3-inch diameter wheel. And then I'm going to look for MKCAD 3-inch stealth wheels. Cool. And actually, there's 2-inch and 4-inch. I don't see a 3-inch here. And when I put 3-inch wheels, I actually only see these squishy wheels, which aren't great for shooting. So it looks like MKCAD doesn't have the 3-inch stealth wheel. So let's go to AndyMark. And see if they actually exist. I'm pretty sure they do. So I go to stealth wheels here, and then I look. It does have a 3-inch option, so that exists. They have it for a 1/2-inch hex and for blue, so the wheel does exist. So one thing I could do is I could download the step file here for the 3-inch wheels. Let's actually just check if there is one in the public library as well. So there's a different. If I go to insert and I go to public, a bunch of files already exist here. I can see if there's a 3-inch stealth wheel that exists within Onshape already. So 2-inch, 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 nope, 4-inch. I don't really see what I'm looking for here. Let's put quotations around 3-inch to only look for 3-inch. Does not look like it exists with stealth wheels. So, okay, so now I'm gonna download this file, this 3-inch stealth wheels with 500 hex bore, so that 500 is 1/2 inch. Next, I'm going to close these, and then so there's no option to import from the insert folder or the insert part. So actually, what you do is you press the plus button and go to import here, and then you're going to search through your folders into my downloads, and then let's import it. I'm going to combine it into a single part studio, I think. Yeah. So that's going to import into a part studio inside of your document. So that new one opens up. Now I can insert that new part that just created itself in its part studio. So I'm going to mate this to my shooter inner circle. Okay. Oh, okay, so now there are actually 2 parts, it seems. So I'm going to go ahead and offset this by 1 inch, a -1 inch to go away from the plate. And then I'm going to do another mate from the circle, the blue part, to the gray inner hub. And I must have clicked one of the wrong faces. I might have done the center of the blue. Let's try that again. So close this guy out, close this guy out, and now this edge to this edge, and boom, cool. Now they're mated. All right, so now I'm gonna do a linear pattern. I'm gonna click the parts that I have here, linear pattern. I want the blue and the gray part, not the shaft. The blue and the gray part. I'm gonna go in the direction of the shaft. And then let's do 2 inches. Oh, these are actually 1 inch wheels, so 1 inch. And then let's make that 3. Give them some thickness. There we go. Cool. And then I'm gonna go in a second direction. I'm gonna go in the direction of the shooter plate. Oh, it rotated. Try that again. Direction of the shooter plate. Oh, why is that rotating? That's weird. But anyways, the distance I'm going to go is the distance from center to center, which is this 4.9 here. So I'm going to go back to my linear pattern for that set of holes. The last one we did. Yep. I'm going to change the second distance to 4.9. And there it goes. Okay, cool. So yeah, it did it in the right direction, but for some reason it's like rotating every time I select something, which is not fun. Then I'm going to do a third direction actually down the length of the shaft. Not this one. Flip this back. In my third direction, we're going to go about 14 is too much. It's going out the edge of the plate, so we'll back that off to 12, and that's at the very, very end of the plate, and we need to go another inch, so we'll do 11. Cool. So this wheel set now should also be an inch away from the other side plate. So now we have all of our wheels in place. And what would actually hold these wheels in place is we would put a shaft collar on the inside and spacer on the side facing the shooter plate. Ooh, this is going to be annoying again. Okay, so I'm going to mate this shaft collar to the inside of this plate here. So that's what will retain the position of that shaft collar. And then I'm going to do another set of linear patterns. I'm going to fast forward this so it's not so much of a headache, but essentially I'm adjusting the dimensions of the linear pattern so that they hit all 4 insides of the wheels. So my final dimensions ended up being 4.9 from top to bottom wheel and then 7.5 for the inside. And I'm not going to model it here, but I would also have a 1 inch spacer from the shooter plate to the end of the wheel hubs to keep that in place. So I only need 4 shaft collars and 4 spacers. Now I'm going to go back to my top level assembly. After I've created a new version of my shooter, I get a blue circle around my arm. I update that arm file, and then it should upload along with my shooter. All right. Oh, and so it's not mated yet, so I need to fasten mate, do this last hole to this last hole, and then solve it, and green check mark in it. Now it's in place. I'm going to hide all the mate connectors so I could see my assembly clearer. But here is the shooter mounted on top of the drivetrain. The sprocket looks like it has some clearance from the drivetrain body, so that looks okay. Cool. Next, what I'm going to do is I'm going to figure out where to mount a motor to rotate this. But for now, this is going to be it. So I have my shooter that's able to rotate within the frame perimeter of my drive.